Now, if you see message types, we saw first message type was open message, and then comes keep alive, update, and notification. But when it is sent only here, third state. If a router needs to send open message, it needs to go to open send state. All right. Now, when open send message is accepted by the receiving router, it will send open confirm. These are all states. These are all not message types. So message type is different. BGP states, neighbor states are different. Now, what are the states we have? Initially, it will be active state. Actively trying to form neighbor, it will go from active into idle. In idle state, what it does is, it takes the neighbor IP address that you configured under BGP. You say no, neighbor 12.0.0.2. It will check whether I have route to reach that neighbor. If route exists, then it will try to do three-way handshake. For three-way handshake to be successful, we should have configured BGP on both routers. For example, both on router 1 and router 2, I should have configured BGP. Okay, if no, the neighborship won't come. We should configure on both with proper autonomous system number, neighbor IP address, update source, everything should be proper. If not, the three-way handshake won't be successful and it will go back again to active state. Once both the side, everything is fine, it sends the very first BGP message called open message, in which router ID, hold time, autonomous system number, these parameters are sent to each other. When those parameters are acceptable by the receiving router will send open confirm to establish session. If something is not properly configured, open confirm will not be sent, rather it will go to active state. Active state. Then it has to go back again to idle, connect, send. Again it will come back. If something is still not fixed, again it will go to active state. It keeps going again. It will never get established until you fix those parameters to match. Like autonomous system number should be correctly configured, IP address of the neighbor should be correctly configured, update source, if it is needed, need to be properly configured on both the routers. All this should be there. Sometimes the authentication. One side you configure authentication, the other side is not. So three-way handshake itself will not be happening if authentication is not proper. It won't go even to open send. Now when everything is fine, it will go to established state, as you see here. When I type on R1, show IP BGP summary, I can see the neighbor is established for last 30 minutes, 54 seconds, and even one prefix is learned. If neighbor is not established, you will find something like, wait a minute, I'm trying to get that, like idle or active, something like that, you know. So if you see some number like this, it is good sign. You should not see active or idle here. All right, so show IP BGP summary is the nice command to verify whether the neighbor is established. But there is also another command, show IP BGP neighbor itself. But the problem is this command is going to show you pages of information about this 10.12.02. See, pages of information. 10.12.02 router ID is this, lot of infos. What you are actually looking for is this one word which is there on the top, established. Just to see this one, you don't need to come to this command which shows pages of info. You can simply type show IP BGP summary to know it, whether it is established up or not. Did you understand? Great. So we have seen this BGP states idle, connect, open send, open confirm, established. And we also saw if it is idle, then you need to have a look into the routing table. Maybe there's a route info, route problem to reach the neighbor address. To check whether it is established or not, I told you two commands, show IP BGP summary, show IP BGP neighbor. This is the neighbor command, which we just saw. And if it is stuck in active or idle for a long time, when I type show IP BGP summary, I'm seeing idle for a long time. Actually, it will also go to active. Very rarely we'll see active, because active is like a fraction of a second it will come, and it will go to idle until the problem is fixed. What are the reasons why it is not forming neighbor? 4 reasons are shown here. If the autonomous system number is misconfigured, you will not form neighbor. If the neighbor statement itself is not configured on one of the router, the neighbor will not come. If one of the neighbor address is wrong, or you should have sourced it with loopback, but you failed to say update source command. Now, if you do any one of this mistake, the neighbor won't come up. It will be in idle state. One good thing is, if you do misconfiguration of AS, you can easily find. Other things, you have to type show IP, show RAN section, router BGP, or show RAN, and then compare, check whether the IP address is correct, check whether the neighbor statement is configured, check whether the source, update source command is given, and fix it. But when you do mistake in AS number, you will be able to figure it out easily. Let me show you. On router 1, what I'm going to do is, I'm going to put wrong AS number. See what happens. Router BGP 10. Neighbor is 10.12.0.2. This is router 2. Remote AS is actually 20. But I'm going to say 200. You see, it will start showing This is the one. It will start very clearly saying peering with wrong AS and FF. As soon as you see FF, you should know that it is related to a wrong autonomous system number. So when you put the right autonomous system number, the problem gets fixed. Okay, the neighbor has come back. That's what explained here. This is how we troubleshoot wrong AS problem. Any question? Okay. This I explained you already. Now, authentication. BGP authentication is the simplest authentication I can say. No need of keychain, key ring, key string, nothing. Just go under router BGP and say, neighbor, this is the address of the neighbor, and I want this password. Let me do it and show you. When you put the password, it will not send the password. Instead, it will send the hash value of the password. Let me show you that. I have already configured authentication here. Show run section router BGP. I have already configured password called ABCD. Whenever it forms neighborship with router 2, the password is this. I have already given. I have already given the same password, which we called as pre-shared key. That's why we called as pre-shared key. Already given pre-shared key on both the routers. So section router BGP. And here also you can see the same password, ABC. As a result, the neighbor is up. If I remove this, what happens, you see? Router BGP 20. No password. Or I give wrong password. Better let's remove it first. I removed it. Clear IP BGP stars. Star. I'm resetting. I'm clearing. I'm resetting, refreshing the neighbor. I lose the neighbor, finish. The reason is authentication. You see, router 1 starts saying that router 2, it is not sending message digest, MD5 message. It is a bad authentication. So neighbor is gone. You can also see that by sniffing the packet with the Wireshark. You see, I do Wireshark now. Now, if you focus here, it looks tiny, teeny, I'll make it bigger. It's easy for me to make it bigger like this. Boom, 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 boom. Because I'm an expert in Wireshark. I love Wireshark. You can do a lot of magics, you see, you will see something very interesting now when I do this. Go to preference. And I say layout. I want layout on the third one as packet diagram. Apply. Look at this. I got the packet diagram. I would like to select router 1 TCP packet and go down to TCP under the option field. Flags. Yeah. If you go down now to the right side, so I just clicked here so that I can easily come here. And then when I go here and see option, okay, I'll take another BGP packet coming from router 1. Router 1, yeah. And then now again, TCP option, I click, here we go. When I open this option and go down here, look at this message digest. I can see the digest here, message digest, hash value. This is the password. ABCD123. See how it is hashed. 7C19 blah 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 blah. Can't read, hash value. Now for router 2, when I check, I don't see that. There is no message registered under the option field. That's why the neighbor is not coming up. Now let us enable authentication on router 2. On router 2, we remove that line, right? I'm going to put it back. Now the neighbor will come back again. It has come back again. You see, the authentication is straightforward, easy. Any question on authentication? Why not? You can do it under peer group also. You can go under the peer group, add this value. Neighbor, peer group name, password. So for multiple IBGP, same password we have to use. That's a good idea. You understood now? Oh, louder please, louder please, louder please. Yes. I'm not getting your question. Can you repeat? See, this password is not for we to log in. This password is for the BGP to check whether the other BGP neighbor is sending, whether the other BGP packets that are coming from legitimate neighbor or from rogue neighbor. This is not for you to log in. This is not login password. This is for two guys, two BGP, to know that they are talking to a legitimate BGP neighbor or not. So that guy sends the packet with the password. This guy checks the password, accepts it. This guy will send the packet with password. That BGP will check it and accept it. It is not for you and me to log in. It's not a login password. Ask question if I didn't answer it. All right. So this is for the routing protocols to accept or reject the BGP packets, TCP packet, BGP related TCP packets that are coming in. Is that clear, everyone? All right. Now this command is the place where we see those networks that we advertise and those networks that are learned. Advertised as well as learned networks. The network that we advertise, the network that we learn is seen here. Okay, we see here. And now if the next stop is this, it means not anyone advertising you. You know it. It is directly connected to you. But when you see a next stop like this, it means this network is a learned network. This network is learned. And this network is actually advertised in this autonomous system, and it comes through this autonomous systems via this next hop and reaching this router A. All this is what we call as attributes. See, BGP is a heavy protocol. Why do we call it as heavy? Because when it is sending the update, it is sending lots of information about the route that it is sending, that it is updating. Lots of information: next hop, AS path, origin, wait, no, no, not wait, local preference, MED, etc., etc., etc. Too many things. Okay. Another thing what we see is there is an order in this output. You see the small number and then the highest number. So the subnets are arranged like this, lowest to highest. The network lower network on the top. Even the routing table you will see the same way in your router. BGP table is also same. You understood? So those stories are coming later, but I am going to explain you. I know where you got that idea asking whether it is IGP protocol. No, 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 no. Don't get misguided with this word IGP. This is different IGP. This is not talking about OSPF or EIGRP. This is internal to BGP. That is that we will be learning these things in detail when we go to attribute class. You understood? All right. There is something to learn from this page which is called this R. R means rib failure. Rib failure. Rib stands for routing information base. Rib failure. Rib failure. Now let's say you have a hybrid car. You have a hybrid car. The car that can run in water. I'm not talking about floating in water. It can run in water instead of petrol. You have a car which can run in water, which can also run by using diesel. Which one you will choose? Water. Cheaper. Because you are in India, water is cheaper than diesel. If you are in Nigeria, you may use diesel instead of water because water is costly there. Depends on the location. Does it mean that there is some failure? No. I am not using diesel here. Doesn't mean that I need to fix and use diesel only. No, 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 no. I have a better choice. I'm using water because that's another option for me. I am happy with that option. I am having rib failure to diesel. That doesn't mean it's a failure. I have to fix it. No, no, no. That's what I want to tell you. Rib failure. Oh, how to fix it? No, you don't need to fix it. This is not a problem that to be fixed. The word may be misguiding you. Failure, failure, failure. No, 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 no. This is not that serious failure that need to be fixed. What does it mean then? It means that this particular network is given by BGP. Also, some other sources giving to this router A. Router A is receiving this network from BGP and also from some other source. Example, OSPF, RIP, static route. In such cases, RIB, what it will do, routing information base. What is RIB? The routing engine, the routing table manager. What it will do, it will ignore BGP because of the administrative distance. See, for static route, administrative distance is 1. So BGP's route is ignored. not taken serious because there is something better. Yeah, that is what here shown as rib failure. It means that BGP's decision is ignored temporarily because there is 172.31.1 a better route by static route or maybe from some other routing protocol source like EIGRP or OSPF. Administrative distance. Lower is always preferred. All those routes be ignored because of administrative distance. BGPs is bigger. The other source giving the same route is lower. Only those routes will be shown here as rib failure. To know this, you can type this command, show IP BGP rib failure. It shows that these two networks are ignored by the routing information manager because of higher administrative distance. It is not a problem to be fixed here. It is saying why I am not able to use it. If you want this to be used, then go and increase the static route value, administrative distance value higher than BGPs. Automatically, this rib failure will vanish if you really want to fix it. According to me, it's not needed. Did you understand? Will anyone go and fix that water facility into diesel facility? No. Water is good than diesel. I can drink, engine can drink, buffaloes can drink, monkeys can drink. Diesel, who will drink? Only engines will drink. Let's go with water. Next, see, whenever we do some changes to attributes or to any BGP policy, to take immediate effect, you have to do route refresh. It will take effect, but it will take some time. If you do not want to wait for a long time for the policy to be applied, if you want to trigger the updates, if you want to impact immediately, you need to do route refresh. This route refresh is of two types. One is remove all the neighbor completely and re-establish the neighbor with the updates, with the latest updates. The other one is don't remove the neighbor, just re-establish one more time by sending the updated updates. Two things, hard reset, soft reset. Hard reset is disruptive. Neighbor is going down and coming up. It is going to disturb the flow of traffic. Soft reset is non-disruptive. So we will be using only, most of the time, soft reset in the production, in the workplace, in the live network. Mostly we will do soft reset. Now, this is the example command. This is the syntax. This is how we do hard reset. Clear IPBGP star. Let me do and show you. See, I'm going to say debug IPBGP. Okay, before I do debug, let me do hard reset. Clear IPBGP star. What a star means? All neighbor. It will remove all the neighbor first. See, it removes the tears the neighbor down and then re-establishes. So I want to show you, it will be sending all the update once again. For that I'll say debug IPBGP packets. Debug IPBGP Updates, traces, topology. I want to see all packets. I don't want only the update. Hey, come on. Events. Events is all. I want to say all. Events. And updates. Okay, let's put event. And now I will do clear. Let's see. You see, a hard reset is initiated. You can see a lot of things. I'll stop the debug. When you do hard reset, the neighbor will go down. The neighbor have to go down and come back again. I think I have to enable another debug to show you in a better way. Updates. Now let's do the hard reset again. Right, you will see even updates are sent. Look at this. Update received, sent. Stop it. You can see a new route is getting learned along with the attributes, updates received, updates sent, blah 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 blah. See, we are just having just two routers and only one network to advertise, only one route to advertise from router 2. Think about millions of routes. It's going to be disruptive. Too much. Removing the neighbor completely and sending is not good. Now let us do soft reset. Here also it will send update and receive, but it won't tear down the neighbor. Clear IP BGP star soft. See, the neighbor is not going to go down. Only the updates are reset. Not bad, okay? Very, very small update. See how neatly it says, these are the networks I have. I'm giving you. These are the networks you are giving me. Okay, good. Thank you. Bye. End of rib. You see? So, you can also mention a particular neighbor instead of saying all. If you want to reset only for one particular neighbor, you can say like this: 10.12.0.2 soft. All right. You can also say in or out, in direction or out direction. Slow, forcefully clear, show peer status, move to original update group, not necessary. Now, let's go back. One particular neighbor also. We can mention both for hard reset and soft reset. You can also say only the outbound updates you refresh, or only the inbound updates you can in and out. Okay, so this is about route refreshing. I did this and showed you debug and clear. All right, so this chapter was really a huge chapter, having lots of information from basic till the advanced level. But still we have one more advanced level to go, which is about attributes in BGP, which is our next chapter. Attributes are the one which makes this BGP a special protocol, you know. If not, we would have gone with OSPF or some other IGP protocol. Whatever you have learned so far is to create BGP, is to configure BGP and advertise the routes through BGP. In IBGP, if it is not advertising, it may be because of IBGP split horizon rule, so you might have used a route reflector or full mesh as a solution. And when you are forming neighbor using loopback, you might have used update source, etc. All right. So we'll stop here. Do you have any question? Not about attributes, about what we have discussed. No questions. Then we'll see tomorrow. We'll continue with attribute. Take care.